So today we are talking about division of polynomials. And something that you are going to need to know is that when it comes to delta math, you don't have to show me work, right? It's just answers. But when we come back from break, you guys are going to have a quiz on all of this, right? Right now we just did addition, subtraction, multiplication of polynomials. Today we're doing long division. The next time I see you, we're doing synthetic division. And then we're going to go on a break for a week and we're going to review it. And then you guys are all going to take a test. It will be a written test. Some of it will have like a photo math problem solved out and you have to explain it. Because here's the thing, I know a lot of you cheat with delta math. I just know it. And I don't want to accuse everybody of cheating. I'm sure there are people who try, but cheating is really easy and there's nothing I can do about it. And I feel like you can cheat your way to a pass in my class, but I'm not going to let you cheat your way to an A. To get an A in a test, you actually have to show me something. So keep in mind that when you are doing this stuff, when you go to do these problems in delta math, you still have to know how to do them, even if you find the answer somewhere else. And if you find the answer somewhere and it's suspicious, like, oh my God, some of your factoring stuff was so suspicious because of the way that you did it, I'm going to start calling you guys into Google Meets and make you explain things to me. Because like I said, if you're going to cheat on homework, I'm not going to hound you for it, but I will hound you on a test. So that being said, I just threatened you all on camera, but not really threatened. We're going to be talking about division of polynomials, and we're talking today specifically about long division. And if you guys remember the last time you did long division, it was like you'd have a thing and you would divide into it, right? Like 1042, and you would do the division in pieces, right? Like if we were dividing this, we go, well, 3 doesn't go into 1. So we'll go, well, how many times can 3 go into 10? And we go, okay, well, 3 times 3 is 9. So we'll put a 3 up here. And we go 3 times 3 is 9. And we would subtract, right, the 1. And we go 142. And then we'd go, well, 3 doesn't go into 1, but it goes into 14, right? 3 times 4 is 12. So we know we've got that part right there. And then we'd go, okay, well, 4 minus 2 is 2. And we'd bring down the other 2. And we go, how many times does 3 go into 22? And how many times does 3 go into 22? 6 times. No, 7 times. Sorry. Which is 21, right? And then we go, okay, we have a remainder of 1, right? Do you guys all remember that? You've all done long division back in the day? That was a yes or no question. You should be typing yes or no into the chat box. What's that?
We are typing.
Where is it? I don't see any of it. Now I felt bad that I was all mad at you guys. My chat box was frozen. I owe you all a big apology. I'm sorry. Now I feel like a jerk. I'm sorry. I am really sorry. I owe you. I'm like, why are they ignoring me? My chat was frozen. It wasn't a scrolling. Now I feel like I owe you some kind of a reward for being mean. I felt like I was being mean. Well, when we're dividing polynomials, it works similarly. Now, here's the thing. If we're dividing a polynomial, so if I have like many times a monomial, we can just write it like a fraction and reduce it, right? If I have, say, for example, 10m cubed plus 40m squared plus 5m divided by 10m cubed, right? If I have something like this, we're just dividing by a monomial, right? This is just one term. The easiest way to handle this, in my opinion, is to write it like a fraction, right? So if I were writing this like a fraction, each one of these is being divided by 10m cubed. I would write this by like 10m cubed over 10m cubed plus 40m squared over 10m cubed plus 5m over 10m cubed. And the reason I do that is because each one of these is piece of a fraction. And now I could just reduce each piece of a fraction. Now, 10m cubed divided by 10m cubed is just 1, right? Any fraction over itself is just 1. And so when I look at this, I go, well, that's 10m cubed over 10m cubed. That's just 1, right? Just like 3 over 3 equals 1. Same thing, right? Here I'm going to go, well, plus, what we've got 40, right, divided by 10. Well, that's 4. But here I have m squared and here I have m cubed. And I want to keep it positive. So I'm going to go m squared. If I cancel these two, right, I still have 1 left here. So I wind up with 4 over m. Do you remember, if you remember from our rules of exponents, we would just subtract the top from the bottom. Here I have 5 over 10. Well, that's 1/2, right? And then I have m over m cubed. So I would just cancel this m. Does that make a little bit of sense to you? Like we just reduced the fractions on it. Is this the solution? It absolutely is. I can't reduce this anymore. Look at that terrible rectangle. It didn't even recognize it as a rectangle to straighten it out. But really, when you're dividing by a monomial like that, one term, you can just write it as a fraction and reduce the fraction. The other way that you can look at that same problem is you can factor, right? But even then, you're still kind of just doing the same thing, right? You still have to do, and what I mean is like you could write it as 10m cubed plus 40m squared plus 5m divided by 10m cubed. And you can do this individually. You could go, well, 10m cubed over 10m cubed is 1. 40m squared over 10m squared is going to be plus 4 over m. And then you could reduce it. Same here, right? Where you'd have plus 1 over 2m squared. But I always think it's easier if you break it up so that you remember, so that you could play with it. You could cross things out where you need to and see what's left. And that's really all there is to it when you're dividing by a monomial, right? One term. Like if we looked at 2a to the 4th plus a cubed plus 2a squared divided by 10a, we would basically do the same thing, right? We would rewrite this as 2a to the 4th over 10a plus a cubed over 10a plus 2a squared over 10a, and we would just reduce each piece. 2 goes into 10 5 times, so we would have 1/5, right? A to the 4th would cancel out that a, and we'd be left with a cubed. Then we would come over here and we go, well, I have a to the third, right? And I have an a down here, so that would cancel, and we'd have a squared left on top, and nothing to reduce that 10. There's no numbers up there. And then here we'd go, okay, well, we've got that 2 over 10 again, and we have a squared up here. So we're going to have an a up here and a 5 down here. And so we would be left with a cubed over 5 plus a squared over 10 plus a over 5. Does that make some sense when it comes to reducing, the way it's just really a reduction with the fractions? Okay. When we're dividing a polynomial by another polynomial, meaning more than one piece, usually a binomial, 2 pieces, it's going to work differently. We're going to have to use actual long division. And the way that works, is we're going to take, for example, k cubed plus 15k squared plus 58k plus 24. And we are going to divide that whole thing by k plus 6. Now, when we have this whole thing that's a polynomial, right? This whole big piece here is a big polynomial. Oops, I forgot to write the k there. K plus. And then here I have a binomial. Bi because there's 2 parts, right? There's the k and then there's the plus 6. And so we have to set this up like a long division problem. One thing we need is, see how this goes 3, 2, 1, and then no variable right here? It always needs to be in that order. If any of your k powers are missing, it doesn't matter where you start. If you start at k to the 5th, you need a k to the 4th, a k to the 3rd, a k squared, a k, and then a constant, right? Those are very important. If you don't have, say, a k squared, you would write in 0k squared. It doesn't change the value of anything. What it does is just make everything line upright when you're adding and subtracting the problems, so that you're getting the actual proper solutions, so that all of your squares end up with all of your other squares. And so we're going to write this just like we'd write any long division problem. I'm going to take the divisor, which is k plus 6, and I'm going to divide into the dividend, which is k cubed plus 15k squared plus 58k plus 24. So now everything is set up just like a regular old school division problem. And so what we're going to do is we're going to look at this k right here, and we're going to say, what do I have to multiply it to get k cubed? What would I have to multiply k times to get k cubed? What would I, so if I have k times k, what do I get? I think I know what you're trying to say, Alfredo. You're trying to raise it up, k to the 2nd power. Yeah, because if I have k times k, I get k squared. If I multiply that times another k, I get k cubed. So k times k squared gives me k cubed. So here I'm going to go, okay, k squared. And I'm going to multiply k squared times k to get k cubed. Then I'm going to take this k squared and I'm going to multiply it times 6 to get plus 6 k squared. We're going to put that in parentheses. And we're going to put a minus in front of it. And we're going to subtract it from the first. So we're going to go k cubed minus k cubed is 0. And then we're going to go 15k squared minus 6k squared is 9k squared. And we are going to bring down the next term plus 58k. So now we're going to do the same thing all over again. We're going to go, well, what do I multiply k times to get 9k squared, right? Now we want to get 9k squared. What do I multiply k times to get 9k squared? Exactly, 9k. Thank you, Alfredo. So up here, I'm going to put plus 9k. And we're going to do the same thing all over again. I'm going to go 9k times k gives me 9k squared. And then I'm going to go 9k times 6 gives me plus 54k. And again, we're going to put that in parentheses and put the minus in front of it because we're going to subtract the whole thing. 9k squared minus 9k squared is 0. 58k minus 54k is 4k. And now we're going to bring down that plus 24, and we're going to do it on this last bit, right? And so now we're going to look at it and we're going to go, okay, well, what do I multiply k times to get 4k? That one's kind of easy, right? Exactly. We're just going to multiply times 4. 4 times k is 4k. 4 times 6 is plus 24. And we're going to, again, put that in parentheses, put a minus in front of it. And when we subtract 4k from 4k, we get 0. When we get 24 minus 24, we get 0. So we have no remainder. And this piece right here is our solution. If we wanted to find all the roots, we could try and do it again and see if it goes through. But this is our solution. There's no remainder in this solution, but there could be. And we'll do some that have remainders as well. But that's ultimately what we're doing. It is tedious, but it's not difficult. The biggest thing with this is to stay organized, right? You have to be organized to make sure that everything lines up. Let's look at another one. We'll do a couple that have some remainders, and then hopefully we will be done in time. I'll try and only do 2 more because I hate to torture you, especially after getting all mad at you earlier and you didn't even deserve it. So if I have, for example, let's go with, I'm going to change this to x because the variable I have is b, and b's always look like 6s. Minus plus 39 x minus 4 divided by x minus 4. Miss Walter's class is out measuring themselves, and they're making a lot of noise. So here we have binomial by binomial. Sometimes you'll see it written like this. Sometimes you'll see it written like over x minus 4. Sometimes this will be written as divided by instead of having the division symbol, but it all means the same thing, right? It all means that you're going to have to take this garbage and set it up like this, at least until next week when you guys learn how to do synthetic division. And then you're like, why did you teach us this other crap when we could have been doing it this way the whole time? Because that's what we do in math. We torture you first, and then we show you the easier way. So here again, we're going to start over. We're going to go, well, what do we multiply x times to get x cubed, right? We're going to go, what do we multiply x times to get x cubed? And since I know it's really hard for you guys to write those square roots into the chat box, we'll just go ahead and say that we're just going to multiply times x squared. And when we go x squared times x, we get that x cubed. And we go x squared times negative 4, and we get negative 4x squared. And then we are going to put it in parentheses and subtract the whole thing. X cubed minus x cubed, just 0. Minus 14x squared minus 4x. Pay particular attention to that. This is minus 4, right? That makes that plus 4x squared, which is like saying negative 14 plus 4, which gives me negative 10x squared. And then we're going to bring down this plus 39x. And so now we're going to move on and we're going to go, okay, well, what do I multiply x times to get negative 10x squared? And we're going to go, okay, well, we know we've got to multiply times negative 10, right, just to get that negative 10 at all. And then we have 1x, we need another one, so we're going to multiply times another x. So it's going to be negative 10x. And we're going to take that negative 10x and we're going to multiply it times x to get negative 10x squared. And then we're going to multiply it times negative 4 to get negative 40x. Actually, that would be positive 40 because we're multiplying a negative times a negative, right? Negative 10 times negative 4. We are going to put this in parentheses. Bam, bam. Put a line under it. And we are going to subtract the whole thing. Negative 10x squared minus negative 10x squared becomes negative 10x squared plus 10x squared, and that just becomes 0. 39x minus 40x just becomes negative x. I feel like I did something wrong here, but maybe not. We'll find out. Oh, no, we didn't. We're just going to have a remainder. So I brought down the negative 4, and we're going to do this whole thing over again. If we look at this problem now, we go, okay, well, what do I have to multiply x times to get negative x? And that would be negative 1. Right? So if I go negative 1 times x, I get negative x. If I go negative 1 times negative 4, I get positive 4. And we're going to put that in parentheses and subtract it. This negative x minus x is the same as saying negative x plus x. So we get a 0 there. But now we have negative 4 minus 4, which just gives us negative 8. And that is our remainder. How do we know we're done and that it's our remainder? X can't go in to negative 8, right? And so this is our remainder, and we would just write this as minus 8 over whatever we're dividing by, which is x minus 4. Does that make some sense? I will probably do a video with some more examples of these, just in case anybody needs them, because I feel like I just gave you an example of each kind. I made sure that you had one with a remainder and one without. Um, but that should be fairly sufficient for you, but I will do a video with a few extra examples in case you need them. Your homework is in Delta Math. Now, I